Hi and welcome to the today's video. The problem is as follows. 3-inch parabolic arch shown in the figure. Determine the reactions at the support. Also determine the maximum bending moment in the arch. Okay, the figure is as follows. Yeah, you came to know the figure. See, they are given in the previous problems we have either a UDL or a point load that is acting vertically. Here they are given 150 kilonewton point load which is acting at T, another one 200 kilonewton point load which is acting at point E. Okay, and these two forces are inclined by an angle of 45 degree and by an angle of 30 degree respectively. Okay, so this is a problem what they are given. They are given the horizontal distance of the arch, that one as 20 meter, and vertical rise exactly at the center is 4 meters. Okay, you have to calculate reactions as well as first you have to calculate the reactions, then you have to go for the bending moment. Okay, then you have to draw the bending moment. Okay, yeah, this is the first step. It will remains the same, finding the reactions. For that we know first step is to find out the reaction. For that we know reactions, that is in order to find out the reactions we know equilibrium condition, f of x equal to 0, f of y equal to 0. Before that, if the inclined force is there, we have to resolve that one into their components. That's what I did here. This is the inclined force, this is the horizontal, and this one is a vertical component. Horizontal component is 150 cos 45, vertical component is 150 sin 45. Okay, here also it will be remains the same because inclination with respect to horizontal. So horizontal will be 200 sin 30 here, and vertical will be 200. Horizontal is 200 cos 30 and vertical is 200 sin 30. Okay, so first I am applying equilibrium condition as we followed for the previous problem. So yeah, summation of f of x equal to 0. Here very important thing is horizontal HA never will be equal to HB. Why? Because there is a difference in the load. That's the reason you will not get the same value. Okay, yeah, that's what I given here. So our reaction HA is horizontal force moving left hand side plus 150 cos 45 moving left hand side minus 200 cos 30 moving right hand, this is moving right hand side, this is moving right hand side, minus 200 sin 30, it is moving left hand side, and HB moving left hand side. These are the horizontal forces. These forces are equal to 0. Equation is follows. And next condition I am considering f of y equal to 0. Vertical force VA plus VB, this moving upwards, minus of 150 sin 45 minus of 200 sin 30, that will be equal to 0. I am considering this one as a equation. Okay, next we have to calculate a reaction. For that we have to consider moment at any point equal to 0. A small change in this one. See here, moment at any point equal to 0. We know vertical distance for all the forces except 150 cos 45, that is YD. Okay, 5 meters they are given for 150 sin 45. Here also 6 meters they are given horizontal distance for 200 sin 30. But what they don't know is 150 cos 45 vertical distance they are not given. So I am considering this one as YD because we know the rise equation. Similarly here also we are following the same. I am considering this one as YV, that will be the rise equation. Okay, yeah, if you consider moment at this point, this tends to rotate clockwise multiplied by this, and this tends to rotate clockwise multiplied by this, and this tends to rotate clockwise multiplied by perpendicular distance here to here. Okay, and 200 cos 45 multiplied by perpendicular distance here to here, that is YE, and this is anti-clockwise. VB multiplied by perpendicular distance, this one. Okay, this is also tends to rotate anti-clockwise. So these two are negative, remaining is positive. Yeah, see here, this is the equation as follows. 150 cos 45 into YD plus 150 sin 45 into 5 plus 200 sin 30 into 14 minus 200 cos 30 into YE, and the once again it will be minus of VB multiplied by 20, that will be equal to 0. Your unknowns is YD and YE. So in order to determine YD and YE, we know the equation of rise. Okay, from the equation of rise, if you substitute the unknown values, then definitely you came to know the other that is ye and ye equation. Yeah, first we are finding the rise equation. This is the rise equation for the parabola, and we know length is 20 meter and rise is 4 meters. Substitute these values, you will get this equation. In this equation, if you substitute x value as 5, okay, x value as 5 meter, this one, then definitely you came to know ye value. Okay, I'm putting 5 in the above rise equation, then yd value is as follows. Okay, this is the rise equation we have. For this rise equation, I'm putting x as 5 meter, then you will get yd value. Okay, that one as 3 meter. Okay, similarly, if you substitute x value as 6 meter, that it was shown in the figure, they are given it x value as 6 meter in the rise equation, then you will get ye value. Okay, substitute ye value as well as yd value in the above equation, that is moment at c equal to 0, that is equation 3. Okay, what I given. So this equation is as follows. This is the equation. Under that I am substituting yd value as 3 and ye value as 3.36. Then you came to know yb value. Okay, substitute this one yb value, because we know summation of f of y will be equal to 0, that we know. Substitute, that is equation 2 I considered. Substitute that one, then you came to know the remaining value. Okay, that is if you know VB value, substitute that one, you get VA value, that is 122.73 kilonewton. Okay, after finding the vertical force, then we have to calculate the horizontal force. For that, we have to calculate both ends, VA and VB, because they are not one and the same, that we came to know from the equation 1. Okay, yeah. For that, I am considering half of the portion, half of the arch. See, the arch is as follows. I am considering left hand side of the arch. Okay, see, this is the arch, so I am considering only this, all this part, that is left hand side of this one. Okay, so that is as follows. Okay, it is similarly this is the left hand side of that one, HA, VB, VA, and these two vertical forces. For that, once again I am considering moment at c equal to 0 for the above load, then VA multiplied by 10 minus of HA multiplied by 4 minus of 150 sine 45 multiplied by 5. Okay, sine 45. Year to year distance, we know year to year it is 10, because half of the span 10, and we know year to year 5, year to year it will be 5, so year to year distance is 5 meter. That what I consider. Minus of 150 cos 45, so we want the perpendicular distance year to year. So for that, what we know means year to year we know it is 4 meter, and we know year to year it is 3 meter. This distance is 4 minus of 3, that is 1 meter. Okay, that what I considered here. Simplify that one, then it will get, then you will get the HA value. Substitute this one in the equation 1 like this. Also you came to know HB value. The thing is, if you feel difficult to find out HB also, you follow this procedure, that is half of the remaining portion also you can calculate. Okay, same procedure what I followed, but you know HA value. Substitute this one directly in equation 1, then you came to know HB value like this. Okay, HA minus HB will be this value. You know HA value, substitute that one, then you came to know HB value. And similarly, you can find out the reactions RA, that is the resultant. So resultant will be equal to horizontal square plus vertical square, and we know direction, it will be vertical by horizontal. Okay, you know this one, we followed the same for all the problems. It is easy, you can calculate directly. Okay, here what I did is, even in order to find out moment at RHS also I considered. Okay, just to simplify, the procedure will remains the same. So if we are doing moment at this point, for this horizontal load, this is the perpendicular distance. For that, what we have to do means 4 minus 3.36 we have to consider. And for this vertical load, year to year is a perpendicular distance. For that, we know it is 6 meter, and total distance year to year it is 10 meter. 10 minus of 6, it will be 4 meter. That's what I considered here. And everything will remains the same. Then you get the HA value. Okay. After finding the reactions, now we have to calculate the here no rise equation also already calculated based on the difficulty of the problem. That's it. Okay, now our next step is to find out the bending moments. So bending moments we have to calculate at the loaded points. We know at the hinges it is always 0, that is at A, B and C it is 0. Then I am considering the portion A to D, because where exactly at point D exactly we are getting the load, and A to D means it is as follows. That is, you came to know from this figure, you came to know A to D. Okay, this portion only we are considering, and that portion looks like this. That portion looks like this. Okay, we have two loads at D and we have two loads at A, and we know ear to ear distance is YD and it is 3 meter. We know ear to ear horizontal distance is 4 meter. I am considering moment at this point will be equal to 0. Sorry, moment at this point, bending moment at this point, loaded point. For that the procedure will remains the same. We have vertical force, here the perpendicular distance is 4, vertical force produces vertical force produces positive bending moment, horizontal force produces negative bending moment. This is the equation. So we know these forces are acting at this point, so bending moment will be 0 for both of these forces because there is no perpendicular distance. Then you came to know that is 47.67 kilonewton meter. Okay, similarly for the another one loaded point, that is point E, also we have to consider half of the portion. See, half of the portion, point E means ear to ear, so this portion we have to consider. This portion we have to consider. So it looks like this. It looks like this. Okay, these two are acting at this point, but we are finding bending moment at this point, so these two will become 0, and we have HB and we have VB, and we know the values also. Bending moment at this point, force moving upwards, positive bending moment, so ear to ear perpendicular distance is 6 meter. HB horizontal force, negative bending moment, we calculated YE value as 3.36 meter by using rise equation. That what I substituted, so the value is as follows. Okay, now while writing the bending moment equation, bending moment diagram, we have to take care that this is a point loads. We have to draw the inclined line and we know this is 47.76 and this one is 229.21. So the units will be kilonewton. So ear to ear, no, we have a point load, so it will be inclined line, and we know at A, C and B bending moments are 0. So 0 to 47.76, then it will reach as 0, and then it will be 229.21, then it will reach as 0, and all the lines are inclined lines because load are point loads. Okay, there ends your problem. It is comparatively different when compared to the previous one, because previously we are dealing with only vertical loads as well as with the vertical loads only. Either it may be UDL or it may be a point load. It will be a vertical load acting, even it is vertical, but the load is inclined, so we have to divide this one into two components, and then we have to before calculating the reactions value itself, we have to take care the rise, we have to take the rise equation, then we have to calculate. Okay, that's a difference we have when compared to the previous one. Okay, there ends your problem. Thank you.